we're going to take a look at one last equation, and then this idea of using functions and operations that act like functions in order to help us find the solution. So what we have written above is that a numerical expression is being related equally to an algebraic expression. So 8 is equal to 3 times the entire quantity of the square root of 2 times an unknown quantity negated, then taken 7 away, finally adding 5. Whew! That is just a mouthful even thinking about it. So, similarly to before, you can express equations horizontally or you can express them vertically. So let's break down that algebraic expression and to figure out just what is happening to this unknown quantity. So we start with our first quantity, which is unknown, and we represent that with an algebraic variable. So the first operation that's happening to the unknown quantity, or x, is how we're going to represent it as a little baby function. A baby function is an operation. So it's being multiplied by 2. After it's being multiplied by 2, the second function, the second operation of the entire equation up there is that it's being negated. And then that answer is going to be having 7 positives taken away from it. After I take my unknown quantity, multiply it by 2, negate that answer, then have 7 positives taken away, the operation that happens next is actually the square root of that result. And you can write the square root as an exponent of a rational number, exponent of 1/2. So it's being raised to the 1/2 power. After it's being raised to the 1/2 power, you're going to multiply by 3. Finally, after being multiplied by 3, after everything has happened to it, these little baby functions that are taking my original quantity, changing it, and then building upon it, the last operation, the last little baby function is an increase of 5. That entire series, an unknown quantity, first being multiplied by 2, that answer is then being negated. That answer is then having 7 taken away. That answer is then being raised to the 1/2 power, or square rooted. That result is being multiplied by another value of 3. And finally, that final move is that answer is being increased by 5. That, all of those changes, all of those little operations that make up the function is being related to another quantity of 8. Through each of these operations and through each of these little baby functions, we can see how our unknown quantity is being changed and compared to our second quantity. So in order to figure out the solution for our original unknown quantity, we actually have to go back up through each of these operations and apply their inverses. So we use the inverses in an inverted order by going back up through it. We will be able to find what our unknown quantity is. So take a look at the very first step that we approach. In our inverted order, we do the last operation first. So we can see that originally you increase by 5. So in order to get to the identity, we need to take 5 away. Add 5 positives, take 5 positives away. That subtracting 5, or taking 5 away, is the inverse of my last operation and will create 5 sets of 0 pairs. We take that answer and we build upon it and we move to the next operation. multiplying by 3 and then multiplying by 1/3. By multiplying by 1/3, that is the inverse operation of multiplying by 3. 3 and 1/3 create a 1 pair. Similarly to the next operation, having something raised to the 1/2 power or square rooting it, you can have the inverse of square rooting be squaring a number, actually raising it by 2/1. And you can see that 1/2 and 2/1, they're actually reciprocals of each other. When you have reciprocals and power of a power, which is the law of exponents, you actually create the multiplicative identity as the exponent. So any number raised to the multiplicative identity as an exponent, which is 1, any number raised to the power of 1 is itself. So we created the identity out of exponents. And then moving further along, we can see that the fourth inverse operation is the original, taking 7 away, but then now we're going to add 7. That creates 7 sets of 0 pairs. Now the next operation is the trickiest. We negated. So how do you undo a negation? Well, the inverse operation of a negation is another negation. You negate the negation. It's a lot of backwards talk for saying I'm doing the reverse of the opposite. So it's the same thing. I'm going to negate the negation. And then finally, the first operation that we performed, identifying from the quantity, is actually the last inverse operation that we perform. So multiplying by 2, we're going to multiply by 1/2, and that is going to create another 1 pair. So when we first read the equation, there was a mouthful. There was so much going on. By breaking it down into the little operations, and then again, building it back up using the inverse operations, we're able to identify the solution with relative ease. So we first start with our quantity 8. Our second quantity 8, excuse me, and we're going to apply our inverse operations, and we're going to take away 5, and then we're going to multiply it by 1/3. We're going to take that entire quantity and square it or raise it to the power of 2. From that entire result, we're going to add 7 positives. That entire result is then going to be negated. And finally, after I negate it, I'm going to take the entire quantity and multiply it by 1/2. Now there's a whole lot going on in that solution, but the cool thing is about math is that it falls apart pretty easily too. So you just start with our second quantity in the innermost parentheses. 8 subtract 5. 8 positives, taking away 5 positives. Well, I know that answer. 3. And then work my way out. What is 1/3 of 3? Hey, that reminds me of that 1 pair. And it is 1. So then I look again. What is 1 squared? Well, I know that an exponent is repeated multiplication. So 1 multiplied by 1 is 1. And then I see that I have addition. 1 increased by 7. Well, that answer, 8. Now I have this negation. What is the negation of a positive 8? Well, that's a negative 8. And finally, the last operation that I have to perform is my last inverse operation, which is 1/2 of a negative 8. And that simplifies to a negative 4. So my solution is negative 4. So let's check our work. We're going to start with our mouthful equation. 8 is equal to 3 times the square root of the entire quantity, 2x negated, take away 7. And then we're going to increase by 5. We'll see if it works with our solution that is equal to negated positive 4. which is a negative 4. I'm going to take that solution, I'm going to plug it in for every time that I see an x. But using our ideas of functions, whatever our input is, which is our independent variable, x, should match with our output, our function of x. So if I have x as my input, and it goes through my series of operations and my series of baby functions that we detailed out on the previous slide, our answer should be 8. We're going to verify it right now. Every time I see an x, I'm going to use my input, which is my negative 4. So I'm going to rewrite the equation. My function of negative 4 is equal to 3 times the square root of the entire quantity, 2 times negative 4, then negated, take away 7. And then we're going to increase by 5. Simplifying a little bit further, 3 times the square root of negative 4 multiplied by negative 2 reacts and becomes a positive 8. Then take away 7. And then we're going to increase by 5. We can see that the quantity underneath the square root symbol simplifies to a 1. So 3 times the quantity of square root of 1 increased by 5. The square root of 1 is a 1. So 3 times 1 is 3, increased by 5. The answer is 8. So let's compare it to the original quantity that we related it to, and that was an 8. So 8 is 8. We maintained equality, so our solution is true.